Hello all, I am Monisha from first MSc Physics. Let's we discuss a topic in quantum mechanics. The topic is commutation relation from fifth chapter angular momentum. What is commutation relation? A commutation relation is the mathematical concept that describes how two operators in quantum mechanics behave with respect to each other. It is defined as the order in which the operators are applied and the resulting values of their products. Linear operators. Let's we took two ladder operators are j plus and j minus, and the value for j plus is equal to jx plus ijy and j minus is equal to jx minus ijy. The commutation relation of jz with j plus and j minus. First we can see the relation of jz comma j plus. Here we substitute the value of j plus, and then we had an equation like jz comma jx plus I into jz comma jy. Then we can write the same equation for minus. Then we have already know that the value of jz and jx is equal to I h cross of jy, and jy jz is equal to I h cross of jx. By substituting these values we can get the equations like jz comma j plus is equal to I h cross jy minus I into I h cross jx. Then we can substitute the values, and finally we can take out the h cross. Then the equation will be h cross into jx plus ijy. The final equation is jx comma j plus is equal to h cross of j plus. Similarly we can relate that jz comma j minus is equal to jz comma jx minus ijy. Here we can substitute the values as the same, and finally we can separate with respect to I and without I. Then we have take out of h cross from the equation. The equation will be minus h cross of jx minus ijy. The final relation for jz and j minus is minus h cross of j minus. Or we can write the first and second equation in compact form. The equation will be jz comma j plus or minus is equal to h cross of j plus or minus. Commutation relation of j plus and j minus mutually. J plus comma j minus is equal to jx plus ijy comma jx minus ijy. Jx comma jx minus jx comma jy plus I into jy comma jx minus jy comma jy. Here jx comma jx and jy comma jy will be 0. So the equation will be minus of I jx comma jy minus of I jx comma jy. Here we have minus 2I jx comma jy. Then the value of jx comma jy we already know I h cross of jz. So the equation will be minus 2I into I h cross of jz. So then the equation is j h cross of 2h cross of jz. The commutation relation of j square with j plus and j minus is, let's just take the j square j plus. J square comma j plus is equal to j square comma j plus plus ijy. Here we already know that the value of j plus is, so we have substitute here, and finally j square comma jx plus ij square comma jy is equal to 0. And similarly the relation between j square comma j minus is equal to j square comma jx minus ijy is equal to j square comma jx minus I of j square comma jy, which is equal to 0. Similarly the combination of 5 and 6 we get j square comma j plus or minus is equal to 0. These are the relationship between the commutation of jz with respect to j plus and j minus. Thank you.